Okay.
Okay, I'll go ahead then. Hi, everybody. My name's Jasmine DeHillig. I'm a software engineer that works at HashiCorp. And my latest project I've been working on is task dependencies for Nomad. So there is a little bit of lag with screen sharing and Zoom, but I think we'll manage. Uh, as Rob discussed before, there are a number of HashiCorp products. Vault, Terraform Console are ones that people are most familiar with, especially if you're coming from a Kubernetes scheduler platform. But we're going to be focusing on Nomad. Of course, this is Nomad Virtual Day, which is really about run and running your applications, which I think has a lot to do with runtime control. So before we get into that, I'll just go over, if you're unfamiliar, a little bit with the Nomad ontology. There's the concept of a Nomad job, and actually this slide is a little bit out of order. So a job is what you will generally use to describe your application, and it can be composed of a number of task groups, which are those four composed of tasks. And the task is the actual workload, the executable that you'll be running. And the reason why there are task groups is so that way you can co-locate certain tasks onto the same client node. And you can also have multiple instances of a task group. So a group of tasks that are co-located onto a node is, when it's actually deployed, it's called an allocation. So these keywords will come up. And so that's where the allocation kind of is. The allocation is the instance of part of a job, specifically a task group running on a node. So going back to what is Nomad all about, you are able to orchestrate your workloads, you're able to deploy things to a cluster, and sometimes you want to have a little bit of control over that. For example, you may want to run one task before another. This may be initialization, some sort of setup before your application runs. And again, this is all co-located on the same node in the same task group. You may want to set up some logging before your batch workload starts running. And so I did a bit of research in the community and figured out that the general use cases that people were asking for was initialization, which could include downloading secrets. One specific example I saw was converting a Vault secret PEM to a Java key store, starting a VPN proxy after the main application is ready, or starting a logging sidecar before your batch workload. Other use cases are cleanup, such as flushing a database before shutdown, and then workflows and continuous delivery. So a lot of people wanted really specific directed workflows for batch jobs to be able to do that kind of data processing pipeline stuff, which that's the experience I have prior to this. So I totally get that. And of course, continuous delivery. So when I was going through doing this research, a majority I found were really asking for a limited amount of task dependency use cases. So specifically initialization before the main app starts, and then cleanup. So thus introduced task lifecycle, which will be released with the Nomad 0.11 release, which introduces pre-start and post-start hooks for initialization. Long-term, it will also have post-stop hooks for cleanup. And it also introduces this new sidecar functionality, which works for both batch and service jobs. But specifically for batch jobs, it will allow you to run a long-lived task within a batch job task group. So a special task within a batch job. So batch job tasks are ephemeral. They run and then they complete, and they'll only get restarted if if they fail. So if they run to completion successfully, they won't get restarted. So the sidecar allows you to run a long-lived task in a batch job, and it'll live for the duration of an allocation. And then in a later release, we're also going to introduce automatic integration with the console service stanza. So that way, that'll allow you to use health checks for sidecar tasks. And the demo. So quickly going to switch over here. Oh, and I'll need another browser. Dun, dun, dun. Okay, well, I'll run this first. So what I have here, let's just look at it so we can see. Cluster configuration file. Oh, is this big enough? Somebody please let me know if my font is big enough. And then I have a cockroach database cluster. And this will download a binary, run with the raw exec driver. And then
someone said it could be one tad bigger.
A tad bigger. Thank you so much. Come on, terminal, work with me. Tad bigger. I'm gonna think that that's good for now.
Yes, all good.
Okay, sweet, thank you. Okay, so we have this cockroach DB cluster and it's got 3 nodes. So node 1, and they're all basically the same, or they're all exactly the same. They run in raw exec driver, which just runs the binary with this command. Fun stuff, fun stuff. And so let's do it. So we're gonna start the Nomad cluster in dev mode, which just allows us to run, so the -dev allows us to run a server and a client all on the same thing. And so it's running. Okay. And now we're gonna run the cluster. Okay, and so let's watch Nomad, and this may be weird because the font is so big. Yeah, it kind of shows, it's confusing. Okay, we're gonna do it short. So this little flag is my best friend. It allows me to see everything. Okay, well, we kind of missed all the action, but it was pending. If you noticed when I had it really big in the full text mode, but in the short mode, it's already gotten to running. So if we go to, okay, so this is correct right now. It's 404 page not found, and maybe I can make it a lot bigger for people. And I'm going to keep going much faster, but we need to do some cluster initialization to get it to work. So I swear this will come out to make sense. So you could look at the logs. Successfully initialized, great. Now let's reload. So it's going to show us lots of stuff in really big font. So this is working. But it required us to do this manual initialization thing. And when you have automated deployments and just like generally infrastructure as code, you don't want to be doing a lot of manual things because it's error prone. If you don't document, like you have to run this initialization line, somebody who on another team tries to deploy the database doesn't know, and then it's broken. So let's shut this down. And, yep. Fine. Okay, so I'm just shutting down the cluster to clear out the cache. just so I have a fresh thing. So now what we're gonna look at is how I use the lifecycle stanza to introduce ordering. So let's get rid of this. Give us a little bit more room. Okay, there we go. We don't need that cluster information. It's Nomad cluster information. It's not as important. So, okay, sorry, just following the chat. So what I did here, it's kind of backwards because post-stop hook is not implemented yet, which we'll get to in a sec. What I did here was I actually made the initialization to be like the main application task. And then I made the nodes, the cluster itself, be a pre-start with the sidecar is true. So why did I do sidecar is true? Well, I wanted to run init to completion, but not have it restart over and over again. So I turned it into a batch job instead of a service job, which allows things to be ephemeral. So this is like pretty hacky, but that's why I'm gonna show you that it doesn't have to be so hacky, but it will demonstrate like what a pre-start hook is and what a sidecar hook is. So I made all the nodes run first. So the cluster starts up. Then once the cluster is ready, it will run the init script. How do I keep the cluster up? Well, I introduced these two hacky tasks to make one of the batch job tasks live forever. So that way it will keep along for the demo and there's a little bit of delay. But basically the nodes, the cockroach database cluster will start up and then there will be initialization. So let's do this. CR. This is also why I introduced a task that just delays. So it gives me time to type in keys. So, these are running and they're pre-starts and they're sidecars. So they're gonna live as long as the allocation runs. And then I introduced a little delay that's also a pre-start. So it'll just kind of like 20 seconds, give me time to talk through what's happening here. And then what we're gonna see happen really quickly is that this is gonna start, or it's gonna be, this is the main applications are gonna start, init is gonna start running and then complete really quickly. And I didn't have to do anything, but this should work. So it's a limited form of ordering. Basically that comes from like the hooks kind of like pattern, if you're familiar with like hooks from other applications like Rails. And it was sort of based off of like run levels. So this is really hacky, and let me see how much I have on time. So I'm just gonna kind of go through really quickly what the code looks like. How did we implement this? So I guess one of the reasons why I talked about allocations versus tasks, and the zoom is like right in the middle. Oh wait, okay, there we go. Because it also corresponds to like what the code looks like. So every allocation, which corresponds to, again, let's look at the job. So every group of tasks corresponds to an allocation, which is actually the thing that's deployed to the client node. And then the allocation will be responsible for running each task, which looks like the alloc runner in the code, which is this like giant file of things that manages it, and the task runner, which actually runs the application. So the way that this primarily works is through Go channels and contexts. So this I introduced this task hook coordinator struct that basically for every like group or allocation or task group, it keeps track of like the main task and what are all the pre-start sidecar and ephemeral tasks are. And there's slightly different behavior for the sidecar versus an ephemeral task. So like a pre-start hook that's ephemeral has to run to, oh no, the editor does not work at all on YouTube. Is it too small?
Yeah, could you bump the font up a little bit? Thanks.
Okay, good thing I already have grandma eyes. Da, da, da. Let's go to like 30. And also, I think we'll try 30, apply it. Is that better? I don't hear anything. I'm gonna keep talking.
Yeah, looks good.
Okay, great. Okay, so there are these two files that are pretty important. Alloc runner, which manages running the actual running of the alloc, and that one keeps track of all the task runners, which run the tasks. Main, and then this is a big task runner run method. It's like way up here. So this is like super crucial, and I swear I'm gonna wrap this up really quickly. So the alloc runner manages all the task runners, and somewhere in there we have a task hook coordinator, which basically the overall idea of it is that it uses Go channels and context to keep track of when should this task be started. And so it just blocks a task from being run until all the conditions are met, which is defined here, start condition for task. You could see that where it's blocking is in the run method right here. So it just waits until it receives a signal from this channel, and then it proceeds and actually does the main stuff. And I guess I could take questions at the end. So how do we add, and I guess I could go back to the task hook coordinator. How do we add how do we add more hooks, basically? So it's going to look something like, let's see the changes. So I'm just adding a bunch of structs to keep track of, and there should be post-start sidecar as well, but I was kind of crunched for time. And then we'll have another one of these right here, keeping track of that, and also have to update over here. So in the alloc runner, there's like a big, where'd you go? It's like a big for loop, like a long-lived Go thread that kind of just like watches the state of all the tasks and then updates the state in the alloc runner. So the alloc runner knows like everything that's happening. And this is where we update the task hook coordinator to manage that. So the task hook coordinator knows, okay, when should I send the signal to the other task to start? So we add another one of these. And there's probably going to be a little bit too much parsing for me. There's a lot in the like parse task and other bits of validation that won't show up here in this demo. They will show up in the branch or in the lifecycle branch upcoming soon. So I'll go back to my presentation. So that's kind of what that, oh, and then here, actually, just to wrap that up, this is what it would look like. Go back. So it would look like this with post-op. It would be a lot simpler. It would be still a service job. And the init task would be post start, not a sidecar. So that way everything just like makes sense. You run all of these as service job tasks, which means that they're going to run forever, or at least until they die or fail. And so what this will do is it'll start the main application and then quickly run this ephemeral post start task. So that's what that's going to look like. Now, going back to the presentation, so I talked before about the use cases, how most people wanted initialization and cleanup and basically a limited amount of task dependencies. But there were still some requests for complicated or complex workflows and also continuous delivery. And that will be addressed not with the task lifecycle hook, but through upcoming ecosystem integrations. Workflows, which effectively require directed acyclic graphs, will be addressed with an upcoming Airflow integration with Nomad. So you'll be able to run Airflow on Nomad and also have that coordinate complex batch workflows, or even use that for continuous delivery for service jobs if you want. But specifically for continuous delivery, we're also implementing a Spinnaker integration, which I won't get into what all of that is. That's another demo entirely. So thank you. I guess I'll answer questions at the end of the presentation or end of the demo virtual day.